Hello guys, welcome back. In this video, let us understood one more important concept, that is how in real time any model will work. Either it may be ML model or GenAI model or large language model. How in real time they will work and provide us the output based on the input that we given. And we also analyze the key terminology or keywords that we mainly use while creating our GenAI application. Okay, let's move to understood how any model will work. So before understanding how any model will work by the intelligence that we provided to that model, so let's analyze how human intelligence will work on any response providing for a specific question. So let's have a question. Let's say this is the person. Let's say he is a person where he already know or he already have some knowledge about AWS services. Now I'm asking a question, that is AWS or is SageMaker belongs to one of the service in AWS? Or let's say the question is SageMaker belongs to AWS services? Is SageMaker one of the service in AWS? Like that, if we provide some question to any one of the human who have knowledge on AWS services, then what do he specify the answer? Yes, it's one of the AWS service, and we use this SageMaker to create some ML models, or you can say GenAI applications you can able to create by using that AWS SageMaker service. So like that, he'll provide the answer. Now, in this scenario, particularly in this scenario, if you observe, so how the process is happening. So whatever the question that we providing, that need to be understood by this human brain, right? Yes. So the first task happening is, so he's taking the question as input. He's listening the question as input, and that data will be taken and processed by using human neural network. So whatever the neural network that this person or human have. So by using that neural network, each and every word in the sentence is analyzed, and this whole sentence meaning need to be analyzed by that human intelligence. Then based on the question, this human intelligence need to observe, or you can say this human intelligence need to analyze the previous, or you can say his knowledge, and based on his knowledge he need to provide the response for particular question that he analyzed, right? Yes. So like that he provided the response. So in the similar way, so how the working of human brain happening in the similar way in GenAI models, or you can say in any ML models, the processing will be happened. In a human, we have our human brains to process any request, or you can say to process the data that is getting. We have our own neural network. In similar way, For ML models or GenAI models, we use neural networks. You can see this is the neural network architecture look like. This is the neural network that we are using in place of human brain in GenAI models or ML models or any models in order to take the input and process the input and provide the response. So in order to take any input, it need to have input ports, right? Yes. You can see the, if we observe the neural network that we are using for our models contains three layers. You can see this is one layer. In order to pick the input or collect the input, we have this input layer. And in order to process, so whatever the input that this layer will receive, that need to be processed, right? Yes. For that, in a neural network, we have hidden layers. By using these hidden layers only, the processing will be actually happen in our neural network. Then we need to provide the response as well, right? Yes. For that, we also have a layer, that is output layer. By using this output layer, our response, or you can see the processed result will be outputted, or you can say provided back. Now you might have a question that arises in your mind, that so how this architecture will be in a human brain. Actually they are connected with some links, right? Yes. Here also there is a joint between each and every circle. Here we call each and every circle as node. You can see here we call each and every circle, either it may be input, either it may be present in input layer or this hidden layer or this output layer. We call each and every circle as a node, and the connection between one circle to another circle, what we call it? We call it as an edge. We call it as an edge. The connection between two nodes, we call it as an edge. Then, so what is a layer, sir? What is a layer? A layer is nothing but a group of nodes. You can see here at output, this is the output layer. At input, this is the input layer. Whereas hidden, you have this is one layer, this is another layer, and this two layers combination, we are calling it as hidden layer. In a hidden layer, we may have either one layer only or two layers only or three layers only. Might it will be depends on your requirement in real time. Now you understood what is a node, and so these nodes, what is the purpose? Either it will take input, some nodes will take input, and some nodes will process the data, and some nodes will provide the output. And how the connectivity happened in between these nodes, either input or hidden layer nodes, the connectivity happened in between these nodes by using edges. And so what do we call all the input nodes as? We call all the nodes as a layer. We call all output nodes as a one layer, all input nodes as a one layer, and in a hidden, how many layers are there? Those all layers we call it as hidden layer. You can see currently two layers are visible. In real time, might be more are there based on our processing requirement. Okay, now you understood how neural network is. So in order to arrange this neural network in specific format so that it can able to take input efficiently and process efficiently and provide output efficiently or accurately, we need to follow some architecture, right? Yes. So that architecture generally, if you take any model, either it may be already available models like OpenAI models or Google based models, or you can say Azure models. So every model will follow an architecture that is transformer architecture. So every model will follow this architecture to provide, to take the input and process that and provide the response effectively. Every model will follow transformer architecture. Okay. Now we understood how neural network will be and so what architecture models will follow in order to provide accurate response. Now let's analyze how any model will take the data and consider that data and process the data and provide us the response. So what is the internal hidden secret that it follow for processing? So let's analyze that in some more detail. Now let's provide the same input that we provided for human brain to this model neural network, or you can say to this model, and let's analyze or let's observe how can we able to generate the output correctly. So for that, let's say I provided this question to this model. Let's say if this model is any one of the language model, that is already we have chatbots, right? Yes, like that. Let's say this is one of the chatbot related model, then obviously it will provide me this response, right? Yes, it will provide me this response back to me, right? Yes, let's say it provided me the response back. Now let's analyze how that provided me this response. So first, any model, either it may be we have multiple models are in marketplace, we have multiple models are there. If we take an example, then we might need to consider open AI model. That is some famous models. Those are those we use in daily life or Chat GPT. So it's one of the open AI based model. And if you observe, then if we consider multiple models, that is multiple famous models that we are using in our daily life are OpenAI developed ChatGPT models and Facebook developed Llama models. So this we use under our WhatsApp itself. Nowadays in WhatsApp, these models are available as well, Llama model. And Google developed Gemma model. That is, you can say we are nowadays most of the developers are using Gemini, right? Yeah. So that belongs to this Google. Similarly, we have multiple models are there. Let's say if we provide this input to any one of the model, then how that model will actually provide me the correct response. So how the processing or how the working will be happen in internal neural network, that is a transformer architecture neural network, how the mechanism will happen, what is happening. So let's analyze that. Now let's say we provided this text-based or conversational input. So this is nothing but, is this an audio input? No. Is this a video input? No. Is this a binary input? No. But what machine will understood? Machine will understood only zeros and ones, right? Yes. So each and every machine will only understood zeros and ones only. But in real time, how actually our data will be? Our data will be either text or voice or audio or video. So like that, our data will be. Let's take the current scenario. Our input is a text, right? Yes, our input is a text. Now, first, our machine need to convert this text into their understandable language, right? Yes, machine needs to convert that data into that machine understandable language. Let's say here machine indicates the model. So how the model will convert this data? So basically it will understood zeros and ones only, right? Yes. So in that format, it needs to convert the data. So whatever the given text input is there, that input will be taken by the input layer nodes. Then that input will be first that input text that will be converted into small chunks of tokens. So how our data will be converted? It will be first converted into small chunks of tokens. Okay. Now let's say the given input is converted into small chunks of tokens. That is one word. Let's take a chunk of token as an one word. Let's take one token as one word. So like that, each input will be converted into small chunks of tokens. So then after, so now also small chunks of tokens are nothing but text data only. Now how these nodes, or you can say how our model will analyze that data, whatever the given data, that data, how it can able to analyze that. So for that, first we need to convert. That means it need to convert into numeric value, right? Yes. So what can actually convert that small chunks of tokens into numeric representation of words? What will convert that text words into numeric representation of words? Those are neural network. By using the neural network itself, the data is converted into numerical representation of text. So what are the text is there? That will be converted into numerical representation. And that we call it as vector data. A new word came, vector data. So how we represented each and every token, of text, that each and every token of text is converted into numerical representation of a text, that is in the form of vector data. So why we need to represent the data in the form of vector? Why not in a single numeric value? The reason for representing our data in the form of vector is in order to capture the semantic relationship. To capture the semantic relationship of a word, we need to represent the data in the form of vector. Let's take two sentences. The one is, I am happy. So that is nothing but my feeling expression, right? Yes. Now let's have one more sentence. That is, are you happy? How this sentence is? It's a question type sentence, right? Yes. It's amazing or somewhat like that. But in both contexts, happy word is used, right? Yes. So if I provide the first question, that is, I am happy, then what is the feeling that I need to get, or how that semantic relation will be stored, that need to be, that happy belongs to a positive sentence, or you can say that that's happy is a feeling expression. Whereas coming to second sentence, that is, are you happy? So in this, the happy belongs to question type word, or you can say amazing word. So only a single word can have two variations right now, right? So based on the sentence, the variation, or you can say the meaning of a word was changing. So in order to identify that, for each and every word, we need to store a vector of data, a vector of data to capture semantic relationship. By using a single numeric value, it is not possible to capture the relationship, semantic relationship. So in order to capture that relationship based on whole sentence, we must need to represent that word as a vector representation. Then only accurately we can able to observe that word or analyze that word correctly. This vector representation of data or numerical representation of data, we call it as embeddings. What is that? Embeddings. So must need to remember this word, because most of the times everyone will fall into mistake, or you can say everyone will unremember or forget this word during their interviews. So must need to remember this word, that is embeddings. So what is the embeddings? It's a numerical representation of text, or you can say it's a vector representation of data that is used to capture thematic relationship. Okay. Now the inputted text data will be taken and that's converted into small chunks of tokens. By using neural network, we got the embeddings. Okay. Then based on the embeddings, what is the next generating token, or you can say what is the next upcoming word that is predicted by using the neural network? By using our model and its brain, our model brain, or you can say whatever the knowledge that we trained our model. Basically in real time, we train our model with a huge amount of data. So based on that data, our model will predict the next one word based on this vector representation of data. Based on that embeddings, it will identify or predict next one word, next upcoming one word for the sentence. And it will identify the whole sentence. You can say the response that we are getting, right? So whenever we type any question or whenever we ask any question to already available chatbot models, then what happens? Each word, one by one word, will be getting as a response. You can say one word will be generated, then next one word will be generated, the next one word will be identified and predicted and generated. Like that, we are getting the response. So like that, at a time, only one word will be predicted and generated. Then after, so one by one, a sentence will be generated and paras also will be generated. Then that whole data or sentences or paragraphs will be sent as an output text. You can say the result for us at the end. So this is what the process happened. Inside, internally, any model, either it may be generative AI model or ML model. So the process happened will be this only. Now here, if you observe, then what is the input? It's a text-based input. And what is the output? It also a text-based output. So can I say the model is taking text input and processing the input and getting the output in the form of text. So that's why we call it as language model. Yes, we can able to call this model as a language model. These language models are again two types. So if you observe the chat GPT, or you can say OpenAI, Facebook Llama model, or Google Gemma model, those we call them as large language models. So why do we call them as a large language model, sir? Because they are trained with large amount of data. Large language models, because they are trained with large amount of data, so we call them as large language models. And even if you observe the model responses are also large responses. Those may be sentences or paragraphs. The predicted output is also very large, right? For these large language models, if we consider ChatGPT, then it obviously provides you a sentence of response, right? Yes. So can I say it's a large language model? Yes. The other type is, you can say this large language model as LLM. In short, we call this large language model as LLM. So the other type of language model is small LLM. Small LLM. So what these small LLMs, or where these small LLMs are used, sir? So while generating, or you can say while using Google, if you type some few letters in Google search bar, then what happens? Obviously, a recommendation will came regarding what is the word might be, right? Yes. So like that, predicting a word based on letters, we call them as small LLMs, because we're getting recommendations, right? Regarding word, what is the word that we are expecting to type, that is analyzed and predicted in a small scale. Either you can take an example of a Google search engine search bar, or you can say in a mobile, if you type the words, letters, then obviously you will get the recommendation in your keyboard. So that those are the two examples that we use in our real time small LLM models. Whereas coming to large language models, I think most of you might use with ChatGPT. So that belongs to one of the large language model example. Now let's analyze this internal process with a small example, so that we can get some more idea about how this internal process is working. So for that, I'm taking the same input, that is this question I am taking as the input right now. Now first input text is given, that is this text is given. Then what happens? A small chunks of tokens will be generated, right? Yes. So let's see. You can observe now. So like this, each and every word will be generated as a small chunk of tokens. So then after, it will be taken as an input. It will be taken as an input by this neural network. So then that data again converted into embeddings. So how the embeddings will be look like? So it's nothing but a vector data representation of numerical values. You can say these each and every text will be represented as vector. You can see here, so each word, how it is so each word, you can see each is represented by these many numerical values. You can see in between there is a so on as well. So based on the parameters and semantic relationships, these values will be defined. So what is the is relation to SageMaker, is relation to belong, is relation to, is relation to AWS, is relation to cloud, is relation with respect to service. So each and every relation will be stored based on whole data. Based on that whole data, actually this is relationship, or you can say the is, or you can say is letter or is word purpose is identified. This word purpose is identified by taking these many vector of semantic relationships and identified the whole word relationship with this word. So like that, for every word, a vector of you can see numeric values will be taken. So based on that numeric values, a final relationship will be identified, and based on those all relationships, you can see that data will be sent to the next layer. So in each and every layer, a compute action will be happened. So in one layer, this is relation will be identified. In one layer, the SageMaker relationship will be identified. So like that, in each and every layer, one particular identification or a prediction will be happen, and those results will again send to the next layer. So in this layer, so based on the inputs that was sent by the previous layer, actually the next upcoming word will be predicted. So like that, each and every time your model will predict only one single word. So like that, simultaneously it will generate the sentence, and if required it also generates you the paragraphs and provide you as an output. So this is how you can see. For here, for this question, what you get the answer as yes. So this you will get as a resulted answer after predicting. Actually, it will provide you this as the answer based on the semantics relation and processing and computing and the knowledge that this neural network has. So now let's have a question. This is the last question. That is how this neural network can create these embeddings or predict the next word. So for that, it need to have some knowledge, right? Yes. So for as a human, we have the knowledge that is based on analyzing the real world scenarios. So in the similar way, we need to train our model, our neural network with a lot of pre-trained data, with a lot of training data. So based on that training, for each and every word, the corresponding semantics will be generated with the relation with by taking the relation with other words, and based on that computational embeddings, it will actually identify or predict the result. So this is what the internal happened in any model, and you can see we have covered mostly all. So whatever the key words or key terminologies that we are going to use in generating our own AI, and you have observed all the keywords or how the internal working of your model will be. Either it may be a large language model or your generative AI application model. So how the internal architecture will be. You have understood the keywords like a transformer, neural networks, hidden layers, nodes, edges, layers you understood. And you also understood LLM, that is large language model, small language model, keywords, and training a data. So whatever the data that we provide to train, that data we call as training a data set. You also understood the very important word that is embeddings. So mostly in real time interviews, this question will be asked. What is embeddings? So what is a vector data? This vector data actually represented in the form of in space, in the form of a document, or you can say your data will be represented in the form of a vector. Sometimes you might want to use the already available documents with your model. So during that time, in order to provide the response from your document by using that model, you need to represent your data in the form of this vector data only. We call this a numerical representation of text data or vector representation of data used to capture semantic relationship as embeddings. So these are the major keywords that you face whenever you go for interview regarding this GenAI related interviews or ML based interviews. So I hope you understood this video and you got a good knowledge on from this video. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys.